Hello and welcome. In today's tutorial, we'll learn how to convert a loop into a recursion. Now, for some of us, when we when we encounter problems that need some iterative solution, we tend to think more in a loop way than to think in a recursion way. This is probably likely due to the fact that we tend to learn loops first before recursions. Like recursions tend to be something developers learn at a later stage than in the beginning. So let's assume we have this example. We have an array and we have elements in the array. Let's say A, B, C, D. We want to rearrange those elements in the array like a combination without repeats. Okay. We can have A, then B, then C, then D. That's it. Okay. Now let's say we want to rearrange them in pairs. Let's say in twos. We can have AB, AC, AD. Then we can have BC, BD. Then we can have CD. Remember, without repeat. Then let's say we want to rearrange them in threes. We can have ABC, we can have ABD, then we can have BCD, and then that's it. Okay, so you can see there is a progression. There's a first level loop, there's a second level loop that rearranges the elements in pairs. Then there's a third level loop that rearranges the elements in threes, and on and on. So you can see that if you approach this problem with a loop in mind, you can arrange it based on all the first, but that's the end of the loop. You may want to arrange it in pairs, and that means you would have to use two loops. You may want to arrange it in threes, meaning you have to use three loops all nested. But what if you want to arrange it in nth, meaning you don't really know the depth of the loop you want to run? This is where recursion comes into play. But because you already have an idea how the loop should run, you can convert that idea of your loop into recursion. You can write it in loop first, any loop. We'll use a for loop in this tutorial, then convert it into recursion. I'll explain how in this tutorial. Okay, so let's say we have an array, and let's say our array is okay. Let's first give a temporary variable. Then let's say the array we want to really work with is this. So I can say 1, 3, 4, 6. Okay, there we go. Now I want to arrange these elements. Okay, so let me just do a quick loop here. So what we can do, okay, let me just say first loop. How this will work is we'll loop across the array, then we'll just concatenate the elements in the array. Look at it. Okay, so what I've just done here is to loop across this array, then concatenate the elements in the array. So I can. Okay, so let's see what we've got. Okay, S. Okay, reload Control Shift I. Then this is the array we have here. So we have 1, 3, 4, 6, 4 elements. Okay, all rearranged. This is simple because it's the first loop. Okay, so it's just spitting out all the elements contained in the array. Okay, let's move to the second loop. Okay, so now we want to arrange it in pairs. This is how we'll go about it. Okay, so okay, I have to be careful here. So So this is a second level of array. And now what we want to do is we want to first loop across this array. Let me comment it out. 1 3 4 6, and this second array here, to create a combination, when we loop across this first one, let's say 1 here, we want to now loop across 3 4 6. So when we loop across, when after looping across 3 4 6, that will be 1 3 1 4 1 6. So the second iteration on the parent array here will be 3, and at that time we want to loop across only 4 and 6. So that will be 3 4 3 6. Then when we loop across 4, the only thing left will be to loop across 6. So that will be 1 3 1 4 1 6, then 3 4 3 6, then 4 6. So as you can see, this means okay, for the first loop we're looping across 3 4 6. So in the end, we're slicing the original array will be modified by slicing for the second array to iterate over while preserving the first, if that makes sense. Okay, so this will be temp. So we want to concatenate. We have to be careful here. Okay, so the first element. Okay, let me create space so I'm not making any mistake. Array dot slice. Alright, thank you. So array dot slice, then I plus 1, then we are going to access j. Okay, so let's console log temp, then look at what we've got. Reload. Okay, so now we have, okay, there's a mistake here. So let me see, temp dot concat array dot slice I plus 1 j. Okay, I'm not slicing here. I meant to have sliced there. So what I was explaining, I forgot. So slice I plus 1, then the length. Okay, yeah, okay, this should work now. Yeah, that was an oversight, sorry about that. So I can commit and reload. Okay, reload this. So now we have 1 3 1 4 1 6. We have 1 3 1 4 1 6 3 4 3 6 and 4 6. Okay, so we can see we have it in pairs: 1 3 1 4 1 6 3 4 3 6 4 6. So now let's make it, let's make this thing to be in threes. We want to have the combination in 3 elements now. So this is how we'll do it in threes, but we have to be very careful here because it involves a lot of brackets and loops and that. But this is just to make it clearer to understand how we transform this into a recursion. So for the third loop now, for creating a combination of these elements in threes, this is how it's going to be. So for, okay, let me just leverage on what we have here. 4, okay, I want that to be I first, then another 4, I want that to be J. Okay, cancel this. Then another 4, I want this to be K. Okay, IJK. Okay, now we're looking across this array here. So here we first have 1 1 3 4 6. In this second array we have 3 4 6, and this third array we have 4 and 6. Now this is on the first iteration of 1. We will slice 3 4 6, and here we will slice 4 6. Okay, now I can delete that. Then it's all about concatenating carefully. So this will be, no, hold on, wait. I've not yet sliced this. I have to slice this first. Almost making the same mistake I made the other time. The length. Okay, let's see. Array dots slice I plus 1. Okay, the length. Yeah, cool. That's for this, just similar to the second array. Then for this third loop, for this third loop, yes, the third loop, we want to slice. See what we want to slice here. We want to slice I plus 1 plus j plus 1, because here we slice the I plus 1 here, but now we want to slice the addition of this and this. So it's not, it's will be this way. It will be array. It's a bit, it can be a bit complex, but it's okay. This is array dot slice. They want I plus 1 plus then the addition of j here. So as this iteration is moving in this second loop, we'll be adding it here, plus j plus 1. Okay, then k plus plus. Okay, there we go. Now time to concatenate. Okay, and then I can come here and say temp, because temp dot concat. Then now, okay, we have to be careful. Okay, temp dot concat. We want to create this array I. Okay, concat it with, that's the first loop. Then for the second loop, we want to concat array dot slice I plus 1, just like what we did in the second loop here. Watch it. Okay, I plus 1. Okay, then we want to access j. Okay, then we want to access the third one, concatenating by the third one be array dot slice I, just this one here will be I plus 1 plus j plus 1, and here we will access k. Okay, hope I made no mistake. So we can save, then come here, then reload. So if you look here, we have 1 through 4, we have 1 through 6, we have 1 4 6, we have 3 4 6. In threes, we don't want to repeat. This is no permutation, so we don't need 4 3 1 1 3 4. So this is what we've got here. So now with loops, as we can see now, we have found ways to find a solution of creating combinations of the elements in stages: the first loop, second loop, third loop. If wanted in fours, we will still have to do this, but it starts to become complex. But what makes the most point here is that there is an established pattern, and it is with this pattern we would switch into a recursion. So to make this a recursion, this is what we will do. Okay, we'll just come here. To make this a recursion, what we want to do is a little bit simple, not so simple. We create a okay, let me can I delete this? Let me delete this. Okay, we create okay, let me just yeah, okay, can I delete this? Should I delete okay, let's leave it. Yeah, so we can create, we should create a function that will take the array and the minimum value. Let's just make it 1, okay, as default value. Alright, then what we want to do now is this. We want to create an inner function. Listen, we create, okay, hold on, let's do it this way. We create a function called combine moves. Okay, then we will create an inner function that will cycle across. an inner function that will cycle across. Now, what is important is this: is that because it's anytime we have a function, a problem like this that involves a first that the loops nest, and we're converting it into a recursion, we must first loop. We must first loop. Okay, we must first loop before we call the recursion. We must first loop before we call the recursion. So it's something like this: for let okay, let's make this I. Okay, so let I will make this the minimum value. It's okay. Then the array dot length, then I plus plus. Okay, then what we want to do here is run a function. Let's just call it cycle moves. We want to run the function first. Okay, now what will be the argument in this function? Let's look at it this way. First of all, we'll pass in the I here, the iterator. We'll pass in the I here, then of course our array that we have to work with. Then we want a temporary value. We want a temporary value here. Okay, that we use to store or collect the rearranged elements. Then we want an all. I'll explain the all later. Okay. So now being said, now we can come here, then create the function. The cycle moves function will be something like okay, let's just say const cycle moves and okay equals function. Okay, so let's just say I array temp all, then there we go. Okay, so now we have to establish a base case for the recursion as usual. A base case and a recursive case. In our base case, usually in most recursions, you see the base case having to return to 0. So let's just make this 0. Okay, then that, then the this will be the recursive base. Okay, let's just this is the recursive case. Okay, so the recursive case will be as we are incrementing, as we'll be reducing, we'll be reducing the iteration. This I, to start from, let's say 1, then 2, then we'll reduce it to 1. If it's 1 here, we reduce to 0. If it's 2, reduce to 1, then 0. If it's 3, when it's 3 rather, we'll reduce to 2, then 1, then 0. Okay, like that. So that way we'll be concatenating. As we are concatenating, it will be creating the rearrangement of the elements in levels, because we are stepping it down for every increment. We'll be stepping it down by 1 for every increment of the loop, if that sort of makes sense. And this recursive case, what makes it kind of easier is because we would just follow the pattern from these loops here, and we'll just lift it and insert it here. So what is the pattern? This is the pattern here. Again, we have to loop a second time, so it's like 2 loops. Okay, so this will be for let j, okay, hold on, for, so you can just say j equals 0 array dot length. Okay, then we want to just cycle the moves here. Okay, so I can just okay, cycle moves. Okay, then this will be, we'll be stepping it down there. Then array dot slice, we'll just be slicing. You see the slice here, j plus 1, I plus j plus 1, I plus 1 plus, so we just simply need to slice only just once. So that will be j plus 1. Then we will just concatenate term dot concats. Okay, just concatenate our array elements here. So that will be array j, then we'll concatenate it to all. Okay, all, return here. Then in our base case here, what our base case would do here is to check this temp. Remember this temp, we have to check for the length and ensure that it is greater than 0, and only when it is greater than 0 we dump it into the okay, this is how it is. Okay, if I equals 0, if temp the length 0, talking while typing, it's quite a hassle, or just all the length, just update the all equals temp. Okay, return here. Then we'll push. I'm not out of the array here. Return. Oh, so yes, there we go. So here we have to push. Let's just push the array here. Then we return all. Wait. For okay, let's say for all. Okay, constant mouse. Okay, I have not defined all. Yes, okay, exactly what I was missing. So that is why it was giving me some gray. So okay, so now we can just combine the moves here. Combine moves, and we'll just pass in the array we have here. Array. Okay. Then reload. Oh, there's a mistake somewhere. 37, 93, 37. There's a mistake somewhere. 37. Oh, okay. No wonder. Okay. Yeah. Now, yeah, that should work now. So if I reload now. Okay, hold on. There's a mistake. Const mouse. Okay, console.log mouse. Okay. And so I can reload now. Okay, then now we have 13141613436 1343646 134136136 and the final one 1346 and the length is 15. Yeah, so just to have a quick recap, this took quite some time. Is this: if you can solve your problem with your first loop and it involves nesting for a second loop and involves a third nesting, what you just need to do is to create a first for loop, okay, then cycle across that array. Okay, then you should just have values of all and temp to just store the rearranged elements. Then you call your function, your cycle moves function. I started with 1 here, not 0. Then you have to step it down. This is like the most important thing. You step it down by 1. Always step down by 1. Okay. As it's increasing, this I1 would later become 3. Then this will become 2 and 1, then 0. Like creating the nested loop. This is the main thing here. This recursive case creates the nested loop. And whenever I hit 0, we just dump into the temp. Okay. We dump into the temp. Then we push and return all. Then console log the moves, and this gives us the rearranged elements. If it's a bit complex, just take time to look at the whole to review the tutorial, and hopefully it will become quite clearer to you. Okay, thank you. See you in my other tutorial. Bye.